All right, so here we are. We're going to take a look at example 7. And again, this is I'm putting a star by this one because they do like this one on the AP, where they give you a picture of the velocity curve. Now, this is different from the problem we just did. Example 6, I gave you a picture of the position function. And you have to be very careful in the AP to make sure that you are not confused and making conclusions based on a position graph when you're really given a velocity graph. So you do want to pay attention to that. This is the velocity curve, the velocity curve. So this is the first derivative. So let's take a look at this and let's remind ourselves kind of what we did on the previous page. What we said previously, the particle moves left when the position decreases, which is when velocity is negative. The particle moves right when the position increases, which is the velocity is positive. And then you stand still when you have an interval where the velocity is 0 because the position function is constant. All right, so let's take a look at that over here. Now, I'm on a vertical line this time, but that does not affect anything in the problem. I have a vertical line where you have some 0, 1, 2, -1, -2, -3. So if we take a look at what our particle is doing, is it starts at an initial, actually I don't know what my initial position is. And that's kind of one of the interesting things here is I don't know my initial position. And so wherever I start, okay, because I don't know my starting position right now, I am going to know that I am initially going to be moving to the up. Sorry, I was thinking that's the same thing. So up is a positive velocity. Good afternoon. Our little announcement there. So since we don't know the initial position, I know the initial velocity. I know how fast I'm moving initially. I start at 2 meters per second is my initial velocity. And then my velocity decreases until I get to 2 seconds later and then decreases a little bit more, and then the velocity increases. However, in terms of my position, the only thing I can do is answer it based on the velocity. So the particle moves down when, I'll put my because, when the velocity is negative. That's what we're going to be looking for. And so the velocity is negative, since this is the velocity curve, we're looking at the portion of the curve that is below the x-axis. And that happens from 1 to this value right here. Now, we're not going to guess. I am going to say, I'm going to save some time here, but what I basically did is I found the equation of this line. We know that this point is 3, -3. We know that this point is 5, 2. And so what I did is I calculated the slope of this line, and it's going to be 5/2. I'm going to let you do that calculation yourself. And then I did the equation of that line, 5/2 x minus 5 plus 2. And then I set that equal to 0, and I solved, and I got 4.2 for that value. So just kind of letting you know what the algebra is I did to get that value. So it's below from 1 to 4.2. And so we'll say 1 to 4.2 when the velocity is less than 0. When is the particle moving up? Again, our reason is going to be when the velocity is greater than 0. And that happens at this location here and at this location here and here. Okay, don't get confused and be thinking about the velocity in this graph increasing or decreasing, because this is the velocity curve. We're looking at where it's positive. So we have 0 to 1 second. And I'm going to put a bracket right here because the velocity at 0 is a positive 2. So that's a positive number. A parentheses at 0 because the velocity is 0 there. And we would have our 4.2 to 6. And again, I'm going to put a bracket on that because the velocity is positive on those endpoints. All right, so then the next question, when does the particle reverse direction? Our reason for reversing direction would be when the velocity curve, v of t, switches signs. And so when do you switch signs? That switches at x-intercepts. So that would be at this location. Go ahead and put it in. I need a color. Let's do blue. So that would be at this location and at that location. So at t equal to 1 second and 4.2 seconds. Technically on these, I might want to, when you write these down, you can probably get away with just putting the interval. I like to do this and then put seconds, and then same thing here, element of, and follow it with units, because I like to have my units on. All right, when is the particle moving at a constant speed? At a constant speed. So we're looking at places where our velocity is constant, because when your velocity is constant, then so is your speed, because speed is the absolute value. At a constant velocity, we're looking at places where it's horizontal. So the velocity is horizontal at this little section right here from 5 to 6. So the constant speed we're moving is for, and I am going to do brackets because it's the same speed. The speed is 2 at 5 all the way through 6. And then in terms of our reason for this, we could say because v of t is constant. And then thinking about this going to the next derivative, we could say that a of t, the derivative of the velocity, is equal to 0. That would be another reason for that when we're looking at it. All right, when is the particle moving at the greatest speed? Now make sure you're looking at this and be careful. This is speed, not velocity. Speed, not velocity. So I might want to come over here and do a quick sketch of the actual speed graph, not the velocity graph. And remember, speed is the absolute value of the velocity graph. So when you're looking at our graph up here, this end right here and this end is not going to change, because the absolute value of anything that's 0 or above the axis is not going to change. What's going to change is this part right here. So we're going to have our slope coming up, and then we have the little jagged piece that goes here, and then you have the part that's coming down here. So this portion is what gets flipped up because of the absolute value, and it makes the velocity become positive. And so we can see that our max location is happening at this little cusp right there, which is at 3 seconds. So in terms of our reason, moving at the greatest speed at t equal to 3 seconds, because speed equals the absolute value of the velocity, and I'm going to point to my little graph that I have over there. Okay. And if I wanted to know what that actual max speed was, max speed is 3 feet per, so we're not feet, we're in meters. Pay attention to my units. Meters per second, which would be, notice, yes, that's -3 down here, but we magnitude, absolute value, flipped it up and it became a positive number. All right, when is speed increasing? Now, I've already done the graph over here for this. This was 1, that was 2, this was 3, this was 4.2, 5, and 6, just to put our values on. So I can actually answer this question because I did a speed graph. But I am going to talk about the reasons that we talked about, and when we started this in class, the notes that we did in class about how do you calculate and how do you verify or justify that speed is increasing. I'm going to write down the answers from here, and then we'll talk about it. Speed is increasing 1 to 2 and 2 to 3 here. I'm going to split this because of the cusp. So 1 to 2 and 2 to 3. And speed is also increasing from 4.2 up until I get to 5, 4.2 to 5. All right. Now, my reason for this is I'm going to use the reasons that is going to be what's going to give you the points on the AP. Is the first thing that we notice is that what we talked about is that speed increases when both velocity and acceleration are working together and they're the same sign. So when you're looking at this part right here, my velocity in these first 2 parts right here, actually the first 3 parts, this is where my velocity is negative. So velocity was negative, velocity was negative for those parts. And then these red parts right here, those are where my velocity was positive. Velocity is positive, velocity is positive. All right. Now, what I want to look next at is acceleration, because acceleration is the idea of putting it together and taking a look at it. Now, remember, acceleration is the slope of these lines. So the slope here and here is going to be negative. So my acceleration in this part is negative. My acceleration here is negative, and my acceleration for this part is negative. My acceleration on this side, once I get past this little peak right here, which is this section right here, this peak, your slope is now positive. So my acceleration is positive, and my acceleration is positive here. And at this point, my acceleration is equal to 0. So that's kind of putting that together. And then if I'm looking for places where the speed is increasing, notice that my acceleration and my velocity are the same sign here and here and here in this yellow. So that's going to be the reason that you want to say. You want to say that these two would be because acceleration and velocity are both negative. So A of t is less than 0 and V of t is less than 0. And then this one would be because they are both positive, A of t greater than 0 and V of t greater than 0. On the AP, you want to make sure that you address both acceleration and velocity when we're taking a look at that. And then when is speed decreasing? And again, I can use this to help myself out. It would be from 0 to 1 and from 3 to 4.2. And those are the two places. And notice, look at your acceleration and your velocity. They are opposite signs on that. So I'm going to say because V of t and A of t are opposite signs. And that will be enough. You could probably say up here because V of t and A of t are the same sign. Because you don't really need to know that they're both positive, they're both negative. They just need to be the same sign. All right, then it wants me to graph the acceleration curve, which is the slope of the curve up here. We already, let's calculate our slopes real quick. I'm actually going to let you do that. I'm going to pause it and save a little time and write my slopes in, but you can do the slopes using the change in y over change in x formula. Okay, so my slopes are -2, -1. We got our 5/2 and 0. So our acceleration graph, so we have -2 for the first 2 seconds. And then we had -1 for the next second. And then we had that 5/2, 2.5 up until I get to 5. And then the last second we have 0. So that's my acceleration curve. So again, this idea of where acceleration is the greatest would be this 3 to 5. So that's easy just taking a look at the graph, 3 to 5 seconds. But I do want to kind of do one last thing before I start, which is this idea of a sign chart. Because sometimes I think it's a little easier to talk about speed if you do it in terms of take a look at the sign chart for your velocity. Your velocity is positive all the way up until it gets to 1, and then it's 0. Then it's negative all the way until we get to, 4.2, which is about here, 4.2. Then it's 0. And then it's going to be positive the rest of the way when I get to 6. And then I can also come in and I can do my acceleration and talk about positive or negative. That's negative. It's technically undefined there, all the way up until it gets to 2. And then it's undefined again. And then it's negative all the way up till we get to 3. And then it's undefined. And then it becomes positive all the way until I get to 5, which is undefined, and then 5 to 6. And then I highlighted on here whether the